Alright, today we're doing perimeter of polygons in the coordinate plane, and we did a little bit of that yesterday, but we'll do more of it today. So it says how to find the perimeter of polygons in the coordinate plane. Well, we can use our distance formula to find side lengths. We can use our Pythagorean theorem formula to find side lengths, or sometimes if we're lucky we can count for side lengths. And then after we find all of our side lengths, we do what we do for perimeter, add all the sides. So I guess find our side lengths first, add them up second. So we're going to practice with a couple problems today. First one, here's our diagram, and it says find the perimeter of CDE. Okay, so I need three sides. The first side I'm going to do is CD because I can count it. 1, 2, 3, 4. The second side that I'll go ahead and find is EC. And if I made that into a right triangle, the legs would be 2 and 2. So my distance would be the square root of 2 squared plus 2 squared. So that would be 4 plus 4 is 8, square root of 8. And then my distance for ED is the last one I need, and it also looks like the legs of a right triangle with ED as the hypotenuse would be 2 and 2, 2 squared plus 2 squared again. So that would be the square root of 8 again. And so if I add these together, I'm going to have 4 plus 2 square root of 8s. And in my calculator, the decimal I'll get for that is 9.66 units for its perimeter. So that would be our first one. Now it wants the perimeter of rectangle BCEF, and they tell us that it is a rectangle, so we only have to find 2 lengths to be able to do this. I'm going to find EC, since I already know it, I found it above. That's the square root of 8, and that will also work. I'll say that it'll also equal BF. Now I need to find EF, which is going to match with BC. And if I made those into a right triangle, it looks like I would have 1, 2, 3, 4, and 4 for the legs. So that would be 4 squared plus 4 squared in the radical. 16 plus 16 is 32. So I would have the square root of 32. So for our perimeter, I have 2 square root of 8s and 2 square root of 32s. And when I simplify that with my calculator, I get 16.97. The next one that they want us to find is ABF. Okay. I think I'm going to have to use Pythagorean theorem 3 times for this one. Let me start with AB. If I made AB into a right triangle, my legs would be 1 and 5. So 1 squared plus 5 squared, 1 plus 25. That would be the square root of 26. Now let me do BF. BF as a radical would be, let's see, this legs would be 2 and 2. So 2 squared plus 2 squared, oh, I had that above, that would be the square root of 8. And AF is last. And if I look at my picture, AF looks like the legs will be 3 and 3. So the square root of 3 squared plus 3 squared, 9 plus 9, that's the square root of 18. So my perimeter is the square root of 26 plus the square root of 8 plus the square root of 18, and in my calculator I get 12.17. Last one is the perimeter of the quadrilateral ABCD, so of the whole picture. So I need the length for AB, which I found above was the square root of 26. I need the length of BC, which I found in number 18, which was the square root of 32. I need CD, which I have found was 4. I could count that one. And then I need AD, and AD has AF in it, which we see from number 19 is square root of 18. It has EF in it, which we found was square root of 32. And it has ED in it, which from number 17 we found was the square root of 8. So I have to add all of those together. And for our perimeter, when we check, that's a lot of decimals, but when we get them all, it would be 27.48. So lots of distance formula, lots of Pythagorean theorem, and lots of parts to add up. And if it doesn't say, we can certainly use decimals to make it a little bit easier on us. Now, I really like this problem on the back. We're supposed to find the perimeter of one small rectangle. And they've given us this picture and tell us that the area of the whole big thing, it looks like that's 9 different small rectangles in the big one, is 180. So I suggest we do this with a system of equations. There are probably lots of different systems, a few different systems you could make. Here's what I'm thinking. If I have this small rectangle up here that they've given me, I'm going to say that this part of it is the length and this part of it is the width. So when I look at my big rectangle, I see that here's a length and here's a width. So that side of the big rectangle is length plus width in terms of the small rectangle. That would make sense on the bottom as well. On the left side of this rectangle, there are 1, 2, 3, 4, 5 segments, and they're all the little widths. So we could label that side as 5 little widths. The other side has 1, 2, 3, 4 measurements, and they're all the little lengths. So one equation I could write is that I know 5 of the little widths is equal to 4 of the little lengths. And another equation I could use is that the area that they told me about. So length times width makes area. So I'm personally going to use the 4L. I'll use that for the width, and I'll use L plus W for the length. So 4L times L plus W is 180. That's another equation I could use. And again, there are more you could make, but these will work. So let me rearrange these in a way that it might be more helpful. I'm going to rearrange the first one and make the first one solved for L. So it would say L divided by 4 on both sides is 5W over 4. And then I can use substitution to plug that into my second one. So it would say 4 and L is 5W over 4 times L again, so 5W over 4 plus W equals 180. Well, on the outside, I get 5W because the 2 4s cancel. On the inside, if I have 5 fourths W plus another W, which is like 4 fourths W, then I have 9 total fourths of W, and it equals 180. So multiplying these two together, I would get 45W squared on top, and this fraction is over 1, so 1 times 4 over 4 is 180. Let me solve by multiplying on both sides times 4. So that 45W squared is 720. Then I'll divide 45 on both sides. W squared is 16. And so W must be 4. Negative 4 would make sense because we're measuring in centimeters. So W is 4. And I can use one of my equations to help me find L. I'm going to use the very top one that I had. So 5 times 4 is 4L. So 20 equals 4L. L must equal 5. And now let's see, it actually wanted me to find the perimeter of one small rectangle. So if my lengths are 5 and my widths are 4, that would be 10 plus 8. My perimeter would be 18 centimeters for one small rectangle.